Welcome back. As promised, our next step is to go through another example of a precipitation reaction to identify the balanced molecular equation firstly, secondly, our total ionic equation, also to figure out our net ionic equation, and to identify the spectator ions. Those are the ions that do not take part in a reaction. So the question we're going to take a look at is in your textbook, practice question 1B on page 427. So that's the question we're going to look at. I don't think the question actually asked for spectator ions, but let's throw it in anyway. So what have we got? Well, we've got cupric chloride, that's copper 2 chloride, reacting with potassium hydroxide. Remember from our double displacement reaction discussion that copper is on a date with chlorine and potassium is on a date with hydroxide, and we get the double switcheroo. So copper is going to end up with hydroxide, and of course, remember it's copper 2, so it's Cu bracket OH2, and potassium will connect with chlorine. So this is our unbalanced equation. Obviously we need to balance it. We've got 2 chlorines here, so let's fix that up, and another 2 there is good to go. We look at our solubility table in our textbook and we figure out that potassium ion is always soluble. Even without looking, we should know that. And copper 2 hydroxide, on the other hand, is our precipitate. So this is our molecular equation. Let's ionize it into our ionic equation. So remember, in CuCl2, really, we've got 1 mole of copper 2 ions. We have 2 chlorine atoms, or ions, so that's why the 2 is there. It's also very soluble. In potassium hydroxide, that 2 belongs to K and OH, so we have to put that in. Look at your table. You should always have your periodic table out to look at your charges because it's your best friend. And hydroxide is OH minus, AQ. Whoop, don't forget the 2 because the 2 belongs to both potassium and hydroxide. So we have ionized our reactants. Now we can look at our products. Remember, this is our precipitate. It stays together as a clump. Let's not ionize it, so we will write it out as it looks. No change there. On the other hand, our potassium chloride is very soluble, so we've got 2 moles of K+, AQ, and 2 moles of Cl-, AQ. So we now have ionized both sides of the equation. Our last step is to figure out which species can we cancel out. Well, it's not that hard to see. Clearly, we have 2 moles of chloride there and there. So they go bye-bye. Likewise, we have 2 moles of potassium ion on this side and 2 moles of potassium ion on this side. What do we have left? Well, our net ionic equation can only involve the ions required to make the precipitate. And lo and behold, if I look at that, the copper is there, and the hydroxides are there, and we've got our clump, our precipitate, copper 2 hydroxide over there. So, metal is always first. There's our copper, and our 2 moles of hydroxide is there. Those are our 2 reactants. And finally, our copper 2 hydroxide is the only product that precipitates. And that, my friends, is the net ionic equation. You kind of know when you get it right because that 2 there belongs to OH only, and we've got the 2 here. So things have to balance out from a charge perspective. We've got 2 pluses here and 2 minuses there, gives us a net charge of 0, and this one is also 0, so we're good to go. And our spectators, like I said, we might have some professional sports coming. We're all hoping for that. In this case, these ions do not take part in the reaction. They go along for the ride, but they really don't do anything. Potassium ion is one, and good old chloride is the other. So that's a good look at a very standard question that deals with figuring out the precipitate from our solubility chart. There's one in Chapter 9 as well as there was in Chapter 4. And identifying spectator ions and coming up with our net ionic equation. I hope this helped. It should also give you some ability to look at the problem set and answer some questions that go along with that too.